This recording is for Primary Math 5. This is the class recording for week 3, preparing you to work on the assigned problems with your student during week 3. This week is a little bit of a lighter week, and you may still be finishing up some of the intensive practice from last week because it was quite a heavy week, but there's nothing in the workbook. In the intensive practice book, we're working on pages 11 through 17, and the there's a recording posted online also for page 12 through 17 because those are all word problems. And then also, of course, the Challenging Word Problems book has a recording posted for working all of those problems. So for the most part today, there's not a lot for me to talk about. On the Challenging Word Problems, remember page 6 is an example page, so I would like for you to work with your student and talk them through, and then just turn them loose. On pages 7 through 10, they're problems that I think that they would be able to do, and certainly if they have trouble with it, of course, the recording is there. It is a challenging section, so they are causing you to think more and more, but the recordings are all up online, and you can help them through any of them that they're stuck on. And so we'll spend a little bit of time today just talking through the intensive practice material, making sure that that is really clear. In the intensive practice book, I again this week did the same thing I did last week. Page 11 has a tremendous number of problems on it, so there is a PDF file online of all those problems with more space so your student can work them correctly and show the work and do things well. Let's talk for just a minute about a few examples of how those work and how your student could show the work and get them correct. For example, on problem number 38, part C, we have this problem written out, and it's again on the PDF, so there's a little bit more room. I would like for your students to start by underlining the part of the problem that they're going to do, and then writing the problem exactly as it is with that part filled in. So we're doing, of course, the order of operations. Please excuse my dear Aunt Sally. We don't have any parentheses in this problem. We don't have exponents. The multiplication and division is going to be done from left to right, and then we'll do addition subtraction also from left to right. In this problem, the first division that I came to was 64 divided by 4. That's equal to 16. The next step we do is to underline that part, and 16 times 7, again, as much as possible, do it mentally. That's 70. And 42, which is 112. 16 plus 112 is 128. And so I would much rather have your student work that on another piece of paper that they have room to write out and space out their work and show it like that, because it's very important to keep it organized and have the work shown clearly. On a problem like letter H, we're still on number 38, on a problem like letter H, we're still going to follow the order of operations. We're going to work from left to right, but notice when I do 54 divided by 6, it's completely separate from the 4 times 5. Whereas on the first page, 64 divided by 4 times 7, I couldn't do two operations at once because they were involving the same numbers. You could actually allow your child, if they see it, if they're comfortable with it, they could actually do these at the same time. I'd suggest that they underline the two of them, make sure they write everything down exactly as is otherwise, and put these together. Then again, if you're doing addition subtraction, left to right, it's a great thing again to underline that. 26 minus 20 gives you a final answer of 6, and that's the correct answer for the problem. They can certainly do this in 2 steps, but as they go and they begin to do things quicker, sometimes we get a little concerned. Are we going too fast? Are they doing it wrong? Can they do that? Yes, that's fine. It's fine for them to add that skill and that step in as they go. We're moving on to some fairly intricate problems. There's a lot of steps in some of these, and so let's work one on number 39. I chose letter F just because of the layers of intricacy involved, and so we have 320, anyway, you have this problem. Because of order of operations, we know we're going to start with whatever's inside the parentheses and simplify that first. So everything else is going to stay the same. I'll have 320 minus 7 times 3 is 21. So 7 times 3 tens is 21 tenths divided by 5 plus 45. Then, of course, I'm going to do the division next. So the 320 minus and the plus 45 just carry on down. I need to do 210 divided by 5. In every 100, there are 25s, so that would be 40 and 2 more 5s, or 42. Again, mentally, what I did was think about 210 as 210, and if it helps, you can even remember that 100 twice, each 100 has 25s in it, and of course the 10 has 2 5s in it. Again, we're stretching that mental muscle. How far can they go? What do they need to write down? How much can they keep in their head? And then we're going to solve this. Now, again, as your student gets better and better, 5th grade, we're working towards a pre-algebra kind of a curriculum. We're working with signed numbers, positive, negative, we're adding, we're subtracting. Have them think about it this. If you have 320 whatever pennies, if somebody takes away 42 and then gives you 45, that's the same thing as just being given 3. We talk about addition, subtraction, left to right, but there's also kind of the next level of math when we say we could combine numbers as long as your signs are correct, as long as you have 42 being taken away and 45 being put back in, that's a net change of a positive 3. You're adding 3. So that's a lot easier to do mentally. I messed up my color scheme. I shouldn't have used green for that. But that's a lot easier mentally to come up with 323 than it was if I tried to do 320 subtract 42 and then put 45 back. The point that if you start with 320 and then you look at the next 2 steps, somebody's going to come and take away 42, but then they're going to give back to you 45 of them. Help them to see the big picture of math. We have to follow the rules, but the rules are a little less rigid than we sometimes make them, and we want to help the kids to understand what does work, what they can do, how to make it happen. Let's go on to number 40. Again, I hope that extra page with all the room on here is helpful to your student. When you look at this, it's a big problem. It looks rather intricate, and it is. But we're going to take it apart and solve it logically. Not doing algebra. We're just doing primary 5 level math. All right, so this little pink blob is what I'm supposed to do first, but I don't know what that is. So I'm just going to call it a pink blob for a minute. And sometimes by calling it a pink blob, I'm very purposefully making it sound a lot less complex than square divided by 3. Right? But I can look at each of these and say, well, I know I'm going to multiply 17 and 9, and I know I'm going to multiply 12 times 2, and I'm going to have this pink blob in the middle of it. So 17 times 9 is 153. I'm going to add a pink blob, and then I'm going to subtract 24, and when it's all said and done, I'm going to be at 138. Well, I don't know what I'm going to add there, but I do know that I can combine these two numbers. If you have 153 buttons and somebody takes away 24 buttons, then we can solve that problem, right? That means that I have 129 buttons. Again, let me fix my color scheme. I have 129 buttons. I'm going to add a pink blob, and I'm going to end up with 138. It must be that what I added in my pink blob, that pink blob has to be equal to 9. That's the only way I can add to 129 to get 138. But if my pink blob is some number divided by 3 and I get 9 as a result, we know that to undo division, you multiply. So 3 times 9 is the number that I started with in that square, and that number is going to be 27. Absolutely, this is a precursor to algebra, but it doesn't need to confuse our students or cause them alarm. We're just taking the problem apart, understanding all the pieces, and solving. First, we solve for a pink blob and realize what's in that pink blob has to be 9. And then once I take that and realize that that's a number divided by 3 that ends up as 9, the only option I have is 27. '42 is an interesting question because it makes them think beyond just the regular math and try to come up with something on their own. And so as we look at this one, we're trying to take all this, just a bunch of 5s, and I get to add whatever sign I want to. I also get to add parentheses if I want to, like the example, and I want to end up with 25 or 0. In their example, they showed us 5 plus 5 minus 5 divided by 5 is equal to 1. So they have 4 5s that they added signs and parentheses to, and we can see, of course, in here that plus 5 minus 5 goes away, so I have 5 divided by 5 is equal to 1, and that works out. So that's the example they give, and they want us to be creative and find our own way to make it work and see what comes up with it. I just looked in the back of the book to make sure my answers are actually different than their answers for the most part, and so there's a lot of ways to do it, and here's what I saw. I know that, I'll do mine in green. I know that 5 times 5 is 25, and then if I could multiply that by 1, I'd be in good shape. So I made this 25 times 1 equals 25. So in here, this is a division. Didn't give myself a very big box to work with. Okay, so that's one way to do it. There's a bunch of them. There's some in the back. Kids may get frustrated about this because it's nice when there's one answer, because then you have to know which way to go and how to find it. When there's many ways to do it, sometimes it's frustrating because it's hard to know the right way, right? But in this case, let your student work on it and figure it out. To get down to 0, if I got these to be the same and I subtracted them, so 5 times 5 minus 5 times 5 is an easy way to get 0. Thinking in terms for 0 of getting them to be the same and subtracting them is a wonderful mental skill, and it just helps us to understand numbers a little better to look at them like that. The next page, number 43, I think is a little easier just because there's lots of numbers to choose from, and as long as you know your number facts, it's not too hard. Let them kind of play with that for a while. I meant to actually write down number 44, just to make sure that we're on the same page of thinking about number skills. On number 44, let me write these down. Often with math, having a methodical way to solve a problem is very good. So if I'm given the digits 3, 5, 7, and 8, and I want to make 4-digit numbers, we can form all of those 4-digit numbers, and I can find that there's 24 of them. Now I wrote them out for you in a pattern to help you see them, help you be able to show your child how to organize them. If I have a 3, 5 with a 7, 8, I could also have a 3, 5 with an 8, 7, or I could have a 3, 7 paired up with 5 and 8 in 2 ways, or 3 and 8 paired up with 5 and 7 in 2 ways. In the same way, I could have the 5 in front, or the 7 in front, or the 8 in front. Altogether, there are 24 numbers that I could make. But wait, we're adding a kink to this, so let's look at, we're not asking just how many are there total. The first thing we actually want to know is how many 4-digit even numbers are there. Usually when we organize these, we think in terms of organizing all the front numbers of 3, all the first numbers of 5, all the first numbers are 7, all the first numbers are 8. But notice when we do this, it works the same way. If you say a number is even if it ends in an even number. So the 4-digit even numbers will all end in 8. There are no other numbers that are even in this set, and so there are 2 in this group that end in an 8. There will be 2 in this group that end in an 8. There will be 2 in this group, don't know which 2 they are. There will not be any in this group that end in an 8 because 8 is the first number. So I know that there are 6 even digits, or 6 4-digit numbers that are even based on these 4 individual numbers to start with. When Part B asks us for the 4-digit odd numbers, we could do it a couple ways. Of course, we could write them all out and count them. We could also realize, if we've analyzed this and we know that there are 24 numbers altogether, there are 24 4-digit numbers at least. If 6 of them are odd, then maybe it's, or 6 of them are even, maybe it's a really quick answer that there are 18 odd 4-digit numbers. Maybe we want to think about that too. That's certainly, it's good to think about just logically, and it's good to think about how it happens. Of course, there's going to be, each number in front is going to have 6 numbers, 6 4-digit numbers with the 3 in front. 2 of them are even, 4 are odd. Same thing here. I'm going to get another 4 that are odd in this pairing. This 7 is going to have 4 numbers that are odd. But think about the 8s. I'm going to have 6 numbers in this group that are odd because they're all odd because the even number is already used up. So if we're counting them, 4, 8, 12, 12 and 6 is 18. Sorry, that's how I know there are 18 4-digit odd numbers in these sets. Part C wants to know how many 3-digit numbers are divisible by 3. There's a trick to that. Make sure that you and your student know that trick really well, and that is if you add up the sum of the digits of any number, this is always true, whatever number you get by, if that is a multiple of 3, if the sum of the numbers is a multiple of 3, then it always is true the number is divisible by 3. That's always true. Now, it's not true of 7, right? If they add up to a multiple of 7, it's divisible by 7. It doesn't work. It's a trick, lovely trick, only for 3s. Actually, it works for 9s, but let's stick for 3s right now. It works for 3s. So here's what we really want to find out. Which of these numbers can I add together and get a multiple of 3? So if I add 3 and 5 and 7, that's 15, and that works. If I add 3 and 5 and 8, that's 16. That's no good. If I add 5 and 7 and 8, that's 20, and that's no good. And the last option of pairing of numbers, probably should put that in the middle, is 3 and 7 and 8, and that's equal to 18, so that does work. So I've written a lot on this page. Let me just turn the page. So what I've just found is, given the numbers 3, 5, 7, and 8, if I want to make a 3-digit number divisible by 3, I could use the digits 3, 5, and 7 as a group, because that equals 15, which is a multiple of 3. I can use the numbers 3 and 7 and 8 as a group, because that's 18, which is a multiple of 3. So how many 3-digit numbers can I make? 357, 375, 537, 573, 735, 753. This gives me 6 options for this set of numbers. There will be likewise another 6 options for that set of numbers for a total of 12 numbers. There are 12 3-digit numbers that are divisible by 3. That's our answer to part C. Now let me tell you one other thing. If their kids are ready for a shortcut, here's something you can do. I'm going to go back to our beginning number. If you have 4 digits and you want to know how many 4-digit numbers you can form with those 4 digits, you can ask your child, how many options do I have of numbers that I could put in this first place? And there are 4 options, either 3 or 5 or 7 or 8. Then we ask ourselves, how many options do I have for the second number spot? Well, now I only have 3 options. I'm not saying put the number 4 and the number 3, but these are how many options I have because one number is already taken. So let's say 3 went in first. I can only choose between 3 other numbers. The next spot, how many options do I have? Of course, there are 2 options. The last spot, how many options do I have? Of course, there's only 1 option. If you, and this is always true, this is SAT prep right here, if you multiply those numbers together, that will always give you the total number of options that you have. The total number of numbers is equal to 4 times 3 times 2 times 1, which is equal to 24, which is what we found on the other page. We actually listed most of them. You can have 24 numbers total, and the shortcut way to get there is here. So with 357, instead of multiplying it out instead of writing it all out like I did, I could say if I have 3 digits, and I'm going to make a 3-digit number, I have 3 options for the first spot, 2 for the second spot, 3 for the third spot. That gives a total of 6 options, and that's the shortcut way to get that number. The rest of the information from this week for Primary 5 is all on the recordings. It's all worked out so that you have it handy.